Okay, so we're going to talk about the solubility of the group 2 sulfates and hydroxides. Okay, so here in blue we've got the sulfates. Magnesium sulfate is soluble. Calcium sulfate's a little bit soluble, and then strontium not very soluble. Barium sulfate is very, very insoluble. Okay, so we've got a clear trend there, decreasing solubility. And here we have got, well, barium hydroxide is pretty soluble, whereas magnesium hydroxide is very insoluble. So we've got, again, we've got another trend, but it's the other way around here. You've got decreasing solubility going up the table. So you've got to remember those two trends. This is in contrast to, we're talking about group 1. All sodium, potassium, salts, they're all soluble, they're all very soluble, whereas not always the case with group 2. And you've got to know those two trends there. Now, you can, the insolubility of barium sulfate is used to test for sulfate ions. Okay, so if you have, so let's put test for sulfate ions. Right, so you've got your sample that you think you might contain sulfate, and you add, first of all, you need to acidify that to get rid of, to avoid false positives. So you acidify, obviously not with sulfuric acid, but usually hydrochloric or nitric acid. And then you add a soluble barium compound. The soluble barium compound you normally use is barium chloride. Barium nitrate is also soluble. And if there are any sulfate ions present, what happens there? You get a white precipitate of barium sulfate. So you can test tap water for sulfate ions, and it does contain a very, so you get a very, not much precipitate, you get a little bit of precipitate, there's some sulfate there. You can use it quantitatively as well. You could filter out the barium sulfate precipitate and weigh it, but we won't really worry about that too much. Now, just to mention why we need to acidify here. Well, it's like, if you remember, if you've been looking at the halogens, why do we acidify a solution? When you're testing for halide ions with silver nitrate, you have to acidify it first. And the reason why you acidify it is to get rid of, to destroy any carbonate ions, any hydrogen carbonate ions, and any hydroxide ions. So if you add H plus, that will turn into, so you want 2 H pluses for that one. You'll turn it to CO2 and water. This one, you'll turn it to CO2 and water as well. You only need 1 H plus there. And the hydroxide you turn into H2O. So it's just to get rid of those. In particular, barium carbonate is very insoluble. So if you had any carbonate ions there, you definitely get a precipitate, but it probably be due to barium carbonate, and you might think it's because you've got sulfate there, and it wouldn't be. So that's why you need to acidify. Okay, so let's just do an equation there. Let's say we had sulfuric acid, because that got sulfate ions in it, hasn't it? Or this could be sodium sulfate, it doesn't really matter. You add barium chloride to that, both in aqueous solution. You're going to get barium sulfate precipitate. And what will be left over? Well, you'll have HCl solution remaining. Okay, just write that ionically. So we'd have 2H plus and a sulfate ion, SO42 minus. Barium ion is obviously 2 plus, 2 chloride ions. You form Now, when it's a precipitate, the convention is you don't separate it as ions. That should be the wrong state symbol there. It should be S. You write it just as that. You don't separate out the ions, and you'd have 2H plus and 2Cl minus ions as well. And obviously they are spectators. And that's really what's happening. Right, so we'll just have a little think about barium sulfate. I think you need to realize that there's a medical use for barium sulfate. It's called a barium meal. X-rays, if you want to look at the gut with X-rays, you can't because they will pass through it. So the patient is given a suspension of barium sulfate. It's insoluble, so it's suspension. That coats the insides of the intestines. And it makes them opaque to X-rays, so then they will show up in an X-ray. And I think they want you to understand here, barium ions are incredibly poisonous, but it's safe to eat, safe to ingest barium sulfate because it is so insoluble, it won't dissolve. It will just remain in your gut. It won't enter your body at all. It'll just remain in your gut and then be digested. Okay, so we'll mention that. Another thing we'll mention about another medical use of is with this one, magnesium hydroxide. Okay, magnesium hydroxide is used as an indigestion remedy. I think it's called milk of magnesia or something. So MgOH, right? It is it's very insoluble, so it's safe to eat. And if you've got acid in your stomach, it will neutralize the acid. There's HCl you've got in your stomach, acid indigestion. So you'll get magnesium chloride and H2O produced and neutralizes the acid. Why would it be unsafe, or quite obviously unsafe, to drink sodium hydroxide? It would do you a lot of damage if you did that. And that's because this is very soluble. And so the OH minus ion concentration is quite high, so it's very alkaline. But MgOH, well, that's insoluble, so it is not going to turn the pH alkaline, and that's what would damage the tissues. So magnesium hydroxide is okay as an indigestion remedy. Right,